So we're going to start with a few simple equations to solve, just to get the right ideas going. First one is this: sine x is a half between 0 and 2 pi. So sine x is a half is one of our favourite well-known triangles. Now we're in radians now instead of degrees. This would be, I'll put the numbers on first, 1, 2, root 3. This would be 30 degrees, but here it's pi on 6. This would be 60 degrees, here it's pi on 3. Don't get confused. Remember, the fractions, the bottom of the fraction is bigger, means the fraction is smaller. 60 degrees is pi on 3, 30 degrees is pi on 6. Okay, if sine is a half, opposite on hypotenuse, sine is opposite on hypotenuse, I'm talking about pi on 6. So that means x is pi on 6, but there's another option as well. So in my unit circle, pi on 6 is here. I'm talking about sine, which is my y value, so the other one's over here. It's pi minus pi on 6, so it's 5 pi on 6. So those are the two possible values. Let's try another one. Sine x equals root 2 on 2, again between 0 and 2 pi. So root 2 on 2 comes from a different special triangle. Root 2 on 2, whoopsie, comes, no, that was a terrible triangle. Root 2 on 2 is this triangle. It's really 1 over root 2. Remember, it's been rationalised. 1 over root 2 is root 2 on 2. 1 over root 2 is 45 degrees, but in radians, that's pi on 4. So that means x here is pi on 4. But again, there's another. We're talking about we're talking about sine. That's the y coordinate. So again, there's another one over here, pi minus pi on 4, which is 3 pi on 4. What if I made that sine x is negative root 2 on 2, just to show you what happens if I'm starting with a negative. Well, if sine x is negative, the number is still the same, so it's still going to be my pi on 4. But it's not necessarily going to be pi on 4. If I ask my calculator for this, I think it's going to tell me negative pi on 4, which is not very helpful. Pi on 4 is where I'm starting, but if I'm negative, I'm down here in the unit circle. I'm looking at this angle and this angle. So this one is pi plus pi on 4, which is 5 pi on 4. And this one is 2 pi minus pi on 4, which is 7 pi on 4. Now you see why we drilled all those fractions into you when you were, in grade 8 and 7 and 8. We're trying to make sure you can do this when you get to this level. Okay, let's try another. Let's try cos. Make it a little bit harder. 2 cos x plus root 3 equals 0. Again, between 0 and 2 pi. So first I have to rearrange the equation until I get cos equals something. So this means cos x, let me do one step at a time for you, is negative root 3. And therefore 2 cos x is that, so cos x is negative root 3 on 2. Well, root 3 on 2 was this up here again. Cos root 3 on 2 is my pi on 6 again. So my reference angle, if you like, you can write it down. Reference angle is pi pi on 6. Okay, just to remind you, and remind myself, adjacent hypotenuse, pi on 6. It's pi on 6, but I'm looking at a negative cos. So in my unit circle, if cos is negative, I'm over here. This one and this one both have a cos of negative root 3 on 2. So this is pi on 6, so it's pi minus pi on 6 and pi plus pi on 6, which means x is pi minus pi on 6 is 5 pi on 6, and 1 over is 7 pi on 6.